Hey everyone, today we're going to be talking about reshaping arrays and manipulating arrays by joining them together or splitting them up using the NumPy library in Python. So you can follow along interactively with me by downloading the Python notebook that's in the link in my description. You can open up the notebook using either Jupyter Notebooks or Google Colabs. Today I'm using Google Colabs. And so this is actually part of a larger notebook. And so at the top of the notebook, actually, it looks like this. And so we're actually all the way down in the section reshaping arrays. And so this is where we're going to start. All right, so if you open up the notebook, just like I have, it's going to look exactly like this. With all of the code basically written in. And so what I'm going to do is describe what the code is doing and maybe just further clarify a few concepts and sometimes write some code from scratch as well. All right, so let's just talk about reshaping arrays. So I'm not going to execute this, but let's just create an array called grid. Using the arange function. And of course, it's gonna, what this function is basically saying is it's gonna start at 1 and it's gonna end at 10. It's gonna have 10 elements. Actually, sorry, I'm gonna print it out now. So it's gonna start at 1 and it's gonna have 10 elements and it's gonna basically stop at 10 but exclude 10, right? And so if you watched my other videos, I really drilled this concept that Python is always inclusive at the very first, with the very first value 1. So it will display 1, and it's exclusive with the last value 10. It won't display 10. It'll go up to 10 and display the last element before 10, which is 9 in this case. So just be aware of that when we talk about very similar concepts in the future. So if I have this, it's basically a one-dimensional array, right? It's 10 elements, 1 row. Well, reshaping allows us to create a multi-dimensional array. And so in this original line of code here, we're actually going to be reshaping it into a 3x3 array. So that just means 3 rows and 3 columns. And so again, the first value in this corresponds to the row, and then the second value corresponds to the column. So we're going to have 3 rows and 3 columns. So you can imagine that this array would look like this: 3 rows and 3 columns. And so just to be crystal clear here, in order for it to reshape, you need to have the math working. So obviously a 3x3 array is 3 times 3, which is 9 elements. You need to have 9 elements in your original array, and that's what we had, right? So we had 1 through 9 basically. And so if I type the 4 here, you would get an error, right? Because a 3x4 array has 12 values, 12 elements. We only have an array with 9 elements, so that's never going to work. So you just have to be crystal clear in terms of getting the math correct so that you have the same number of elements when you reshape than before you reshape. So that's a very important concept to memorize and to note. All right, let's do a few more examples. Let's just create I'm going to comment this last line out. Obviously this is going to create an array that's 1, 2, 3. Sorry, let's display it 1, 2, 3. And if we want to reshape it so that it's 1 row, 3 columns, what would that look like? It would probably look exactly the same, right? That's just to confirm that we know what we're doing. So now let's actually create an array that's 3 rows, 1 column with this array that we have here, which is stored in variable x. So in order to do that, we just, if we want 3 rows, 1 column, all you need to do is specify 3, 1, and that's what you get, right? So the original, what I'm going to do is I'm going to print the original array, and then I'm going to print reshaping the array. So the original array was 1 by 3, and this new reshaped array is, 1 by 3 and then 3 by 1. Another way of doing it, it's not super obvious, and I don't really use this a lot, is this new access function or attribute. And essentially what it'll do is it'll just transpose the array. So if your array is 1, 2, 3, it's 1 row by 3 columns, this new access here is just going to transpose it. And so what you're going to get out of it is an array that looks like this, 1, 2, 3. But it's exactly like using this reshape here. So to me, this is a little easier because it explicitly calls out 3 rows, 1 column. And so if that's what you want, then use it. And you know every time what you're going to get, even if you forget exactly what the output is going to look like, just by reading this function that you're going to get 3 rows, 1 column, right? So that is reshaping arrays using the reshape function. So now let's talk about concatenating arrays, so joining arrays together and splitting them apart. So there's a very nifty function that NumPy has that makes it easier for you. It's called concatenate. So I'm actually going to comment that function out. Let's just create two arrays, x and y. So I'm going to print x, and I'm going to print y. Should be 1, 2, 3, 3, 2, 1, right? And so I want to join them together now. And so if I concatenate, so now I'm going to delete that. If I'm going to join these two together, these arrays just are joined into one larger array, right? That's the default behavior of this concatenate. Basically, we have 2 arrays that are one-dimensional. We're just going to put them together just like this. So x and y, x is first and y is second. If I flip them, you guys can probably guess, I get the y first and the x second. All right, and so now if we want to add a third array, right here we have another z array or z list. You basically get it at the very end. You get 999 joined together with x and y. So that's a really easy example of the function concatenate because we're just dealing with single dimensional arrays, right? 1 row, multiple columns. So what happens if we have a 2-dimensional array? So if we have grid here, we have an array that's 2 rows, 3 columns large. So if we concatenate this, let's just look at what the default behavior of this concatenate does. If we put 2 grids together, basically they stack on top of each other, right? We can think of this as like a vertical stack. So that's an easy way to understand and memorize the default behavior of concatenate. So there's also a parameter of this function called axis. And it's basically like how you want to join these 2 arrays. Do you want to join it on axis 0, which is the default? So if I actually did axis equals 0, I'm concatenating it on the quote unquote 0 axis. So it looks exactly like it does now. So the 0 axis, you can think about it as just stacking it on top of each other. You can also think about it as vertical stacking. And then this axis 1 is joining it together on the horizontal axis. And let's just execute this line of code and see what it outputs. So now you see that the rows are joined together, right? Because I'm going to print out grid real quick. Maybe I'll print out grid again just to explicitly illustrate. You see on axis 1 that this first row here and this first row here are joined together into one array. And then the second row here and the second row here are joined together in one array. So that's what a horizontal stack does. And in this case, axis 1 is what you would need to join these two arrays on a horizontal axis. All right. So now actually let's not use concatenate. Let's use more explicit functions. We're gonna talk about vertical stacking and horizontal stacking. And I sort of already introduced those concepts to you with axis 0 and axis 1. So if we go down here, I'm going to actually just comment out this, and I want to print X and I want to print grid just to illustrate things more explicitly. We have 1, 2, 3, which is X, and we have a two-dimensional array, which is grid. And what we want to do is we want to stack them on top of each other. And that would require a vertical stack, right? That's what the definition of a vertical stacking means. It's just putting it on top of each other. So I'm going to just remove this. I'm going to execute this line of code here. And what I'm going to get is exactly that. So X is now vertically stacked on top of the grid array. And this works because even though we don't have the same amount of rows, we have the same amount of columns. You're not going to be able to vertically stack something like this, where my X array has 4 columns, but my grid array only has 3. Yeah, it's going to throw an error saying basically the number of columns don't match. So I'm going to fix this real quick and get this working again. That's what we have right here. All right, so now what if we want to horizontally stack things together? And that's just like what I was talking about with the axis 1 parameter of concatenate. We're basically going to be putting 9, 9, and 9, 9 on the grid axis. And so we're going to join them horizontally. So let's actually just not run this yet. I want to illustrate my point. So what I have here is 9, 9, and then I have a 2-row by 3-column grid array here. And so I basically want this 9, 9, this Y array to just horizontally stack to the right of the grid array. And so in order to do that, I'm just going to do a horizontal stack called hstack, the hstack function. And because I want the grid to be first, it's going to be the first variable that I put in, and then the second one will be Y because I want the Y array to be on the right hand side. And I get that. So that's a horizontal stack. So we talked about joining arrays together. Now let's talk about the opposite concept. Let's talk about splitting arrays. And splitting arrays is actually rather easy. We're going to be using the split function. So what I'm going to do is I'm going to actually comment out a bunch of things just to illustrate my point again. Oops. So I'm going to print out an array that we're creating. We're creating a one-dimensional array with these values here. And I want to just basically split them. I want to split them into 3 arrays because I want to basically take out this 9, 9. I want 1, 2, 3, then I want a second array to be 9, 9, and I want a third array to be 3, 2, 1. So I want to split on basically right after this 3rd position, and I want to split right after this 5th position. And here's again this inclusive exclusive concept that I've been drilling in with my videos. So again, we have this nomenclature here with this bracket 3 and 5, but it has a parentheses. And if you've seen my previous videos, we know that this solid bracket means inclusive and this parentheses means exclusive. And this is the way Python works, is that the first value, the first parameter is always inclusive, and the last parameter is always exclusive. And so what that means in this example here is that if I want to split on the third position, I'm gonna, if it's the first parameter, I'm gonna actually call out the third position. So it's 0, 1, 2, and 3. So this is the third position. And then the fifth position is 0, 1, 2, 3, 4, 5. This is the fifth position. But since it's exclusive, it's actually gonna split on this 9, 9, right before the 3, right after this 9, 9. Sorry, right here. So it's sort of like a confusing concept, I guess, where, you know, inclusive, this is the third position, and then exclusive, this is actually the fifth position, because the fifth position is actually right here, but it's gonna, because it excludes the fifth position, it actually splits on the fourth position, right? It's sort of confusing to memorize. Another way of thinking about it is, with the split function specifically, it's going to split on the third and fifth, like right after the third number and right after the fifth number. That's a really easy way to think about it, right? Right after the third number is here, right after the fifth number is here. The danger of thinking like that is it only works for, you know, this function, the split function, because it's sort of easy to memorize that. But really what I would do is try to memorize the concept of the first number being inclusive and the second number being exclusive, because that's really the way Python works. So let's now just go back to splitting. So what I'm going to do is I'm going to basically use the split function. The split function requires two parameters. It requires the array that you want to split, and this is basically this array up here, and the positions in which you want to split. And you have to put these brackets in because you are passing this set of parameters as one object into the split function, and you're saying I want to split on the third position and I want to split on the fifth position. So what does that look like if I execute the split function? It does give me 3 arrays, right? That's exactly what I want. But this is not saved in any variable. I actually want to save these arrays into variables of their own. And so if I run the split, it actually gives me 3 variables. So what I'm going to actually do is I'm going to say, you know, the first variable, I'm going to name it x1. And it's going to basically have, it's going to basically store this array here, comma, x2, which is, I'm going to say is this middle array, comma, x3, which is this last array on this right-hand side here. So if I do that, and then I'm going to print x1, x2, x3, I basically get these 3 arrays stored in these variables here. That's exactly what I want. All right. So now what we're going to do is split on the vertical stacks and horizontal stacks. So basically the opposite of concatenating on the vertical and on the horizontal axes. So let me just create a 4x4 array called grid. And so I have a 4x4 array here. And so what I want to do now is I want to split vertically, which means I want to split like on a row. And I have this 2 here, which means that I want to split on the second row. So like right after the second row here, I want to form a split. So I'm going to have one array called upper, which is here, and one array called lower, which is this one here that's highlighted. So if I do that, I'm going to use the split function here, which requires 2 parameters. It requires the array that you want to split on, and it requires the position you want to split on. And that's exactly what I get. So this split just requires one number, but remember you have to put it in these brackets because we're passing one parameter to the vsplit function. All right. So now if I want to actually split horizontally, which means I'm going to split just up and down basically. I'm going to split right after the second column, but right before the third column. So that's position 2, as I've stated right here in this hsplit function. I'm going to split right here. So my left is going to have the first 2 columns, my right is going to have the last 2 columns, and that's exactly what I get. I get the left-hand array and I get a right-hand array. And I'm using this function called the hsplit. And again, it uses the same parameters. It uses 2 parameters, what your array is, and then the position in which you want to split. All right. So that takes care of all of the concepts, basically concatenating and splitting arrays and manipulating arrays.